Hello and welcome to the eTech podcast with me, your host, Ryan Maughan. I have been involved in the development of electrified vehicles and machines since 2005 as an engineer and a business leader. This podcast is the product of my passion for electric and autonomous vehicle technology. I'm here to share knowledge from some of the world's leading experts as well as my own insights. Join me as we accelerate the transition to cleaner, safer and smarter vehicles and grow the industry around the world. For today's episode, we've got Kevin Brundish from AMTE Power to join us on the show. You might have seen AMTE in the news recently. They are a battery cell manufacturer based in the UK, and their background story is absolutely fascinating. So Kevin has very kindly agreed to come on the show and talk to me about the plans that they've got, what they're working on, background to the company and the battery industry as a whole. So welcome to the show, Kevin. Thanks for joining us.
Morning, Ryan. Yeah, delighted to be here.
So if we could just start, Kevin, just a bit of an introduction to your good self and your background and where you came from would be great.
Yeah, no problem. I mean, I started my career as an engineer, actually, building or designing, I should say, designing aircraft parts, gas turbine parts, actually. So that's longer than I care to remember, but 25 or so years ago. And I worked for a number of different companies, such as Rolls-Royce, and I ended up working for a technology company called Kinetic.
Right.
And whilst there, I sort of moved into more managerial roles and led the battery and fuel cell business. Probably some 10 plus years ago, I started in this field. Therefore, so compared to some, I'm a newcomer. But nonetheless, been in the sort of battery and fuel cell business for over a decade.
Fascinating. And good to know you from an engineering background as well. I think all the best people start their careers in engineering.
Absolutely.
And then, so at Kinetic, that's kind of where the AMTE business journey starts. So could you just tell us what happened and how that came about?
Yeah, absolutely. So well, in fact, I actually joined a hydrogen company for a short period of time, for a couple of years as a sort of startup. But in 2013, I got together with a couple of ex-Kinetic colleagues, and we set up AMTE Power. And what we really did was we bought a business called AGM Batteries, and I'll come back to that in a second. But really, we'd had a lot of interaction with AGM over the years, a cell manufacturer in the UK that specialised in supplying defence. And of course, because I was in Kinetic, there was always a defence and aerospace element to the work we did, because it was primarily a defence and aerospace company.
Yeah.
So when that business was available to be bought, we set up AMTE and we bought the business. So that was 2013.
And AGM, just remind the acronym stands for something, doesn't it?
Yeah, no, it does. There's a reasonable amount of history behind AGM, actually. So I'm going to get into a few acronyms here.
Right.
Okay. AGM is an acronym, so it's the A stands for ABSL, and ABSL stands for AA Battery Systems Limited, and then AA is the Atomic Energy Authority. So the A is the common part.
Yeah.
So that goes to ABSL, and they set up they actually had the patent for the early lithium ion. So they worked with Oxford University and did some of the original licensing out to Sony and were part of that whole commercialization piece.
Okay.
So the business up in Scotland was slightly later than that. It was a joint venture in the sort of mid 90s, really, between ABSL, with all those links, GS Yuasa and Mitsubishi Materials. So that's the 3A. Yeah, that's the 3-letter acronym that you get AGM
Right.
from.
The Atomic Energy Authority piece in that, why were they making batteries? What was the link there?
it was, I think if you go back a number of years, AA was a diversifying business. I never worked there, so I can't talk specifically about what their business plans were, but they were all about energy. And they worked in quite a diverse portfolio. So if you look at the work that goes on there was quite a lot on nuclear, obviously, but it went beyond that into peripheral energy technologies and products that would help that industry. So the battery side wasn't entirely unlinked in that sense. It was something that was felt could be a link into energy in general.
Yeah.
So they were working with Oxford University and others. So that's sort of where that whole lithium-ion story started with AGM, with ABSL. And the sort of links with GS Yuasa and Mitsubishi Materials were all about setting up a joint venture that was going to look at verifying the supply chain, in essence, looking at what different materials would make a good lithium-ion cell, what variances could be tolerated, generating processes and helping those companies go on and become giants in the field. So in reality, it was right at that sort of conception of lithium-ion as an industry,
right,
and really involved very early in that sort of commercialization piece.
And was that the intention? So rather than being a kind of a JV that was there to exploit the technology, it was really a JV that was there to help develop and industrialize the technology. Is that the kind of right sort of way of thinking about it?
Yeah, that's sort of that starting point. But of course, it had rights to then exploit.
Yeah.
As well. So actually, the history moves on a little bit in the ABSL essentially took back complete ownership of the business, AGM, and then became a producer of cells. And it was always focused on, high end, high quality. I hate to use the word niche, but niche compared to today's markets.
Yeah.
Niche end users. Primarily, it got some work in defence and has supplied, defence contracts, for a couple of decades now.
Right.
So it's been doing that for some time. But over time, of course, the rest of production scaled up. Hugely, prices were driven down, and eventually the competitive nature meant that buying those cells from overseas was a reality.
Right.
So we took that business on in 2013. I think we sort of took it back to its roots in a way, because we recognised that whilst there are a number of markets that we could still serve, really its best use for us was to look at bringing new technologies, to market.
Yeah.
Utilising that hugely expensive setup, equipment that was already there.
And the there is an interesting part of the story as well. So
it is. Yeah.
Where is it?
Yeah, it's in Thurso, which, if you're a frequent traveller to the Orkneys, you will have probably passed through.
Yeah.
Through a particular port called Scrabster, but yeah, it's up on the north coast of Scotland, and there has a part of the AA link, the Atomic Energy Authority, in that back in the 90s, or in fact way before the 90s, there's a nuclear plant up on the north coast of Scotland that was being decommissioned essentially.
Right.
It was one of the very early nuclear power facilities, if not the earliest, in fact.
Yeah.
In the UK. And the Atomic Energy Authority was obviously working with the local area to look at job retention and things like that, and eventually decided to place the battery factory, in Scotland. I think there might have been some other aspects, such as whiskey, when the link came with Japan, but I wasn't in those negotiations, so I don't know. but there's some other links there. But you're right. It was in part to look at maintaining sort of level of jobs in that region,
right?
That AA had given the power station. As it happens, that decommissioning isn't as easy as was thought back in the 90s, and it's still undergoing decommissioning.
Wow.
It's taken a lot longer.
And drawbacks of nuclear power.
Some of the downsides, when you want to stop it, takes an awful lot of money and effort to take it to pieces. I'm sure designs have improved since then, but that's ongoing.
And Thurso is, it's a beautiful location. Not really sort of industrial heartland of Scotland, though, in terms of the manufacturing footprint and things up there. It must be quite a... you guys must be really significant business in the area.
Well, absolutely. We employ around 50 people now up in the North Highlands. But as compared to the nuclear site that takes on around 1,500, and I think that's worth noting that the skill base that's in that region is very high. I think outside of that cluster, obviously there are other, whiskey and fishing and agriculture are big industries along with tourism. But there's certainly a large technology-based talent pool up in the North Highlands that you probably wouldn't expect.
Okay.
Primarily because in the early stages of the nuclear development, a lot of people went there. So we're working with sort of third generation nuclear physicists, which you might not find in other parts of the Highlands.
Oh, wow.
So it isn't quite as you expect. Hidden away are some substantial sort of engineering and technology based businesses.
Oh, fantastic! It sounds, combine that with the rugged scenery and some amazing whiskey, and sounds like you've got a good combination.
It's a great combination, and it's got a degree of isolation, which in the current times helps a little bit as well. Yeah. Social distancing is relatively easy to achieve, for instance. So there are some strengths, and of course, some of the challenges are transit there, but again, it's not too bad, and it is a beautiful journey up through those highlands to the north coast. Fantastic.
And so just tell us about the existing facility that you have up there. What is it? What have you got?
So we have a full cycle manufacturing plant. So I think the phrase we like to say is powder to power. Essentially, we bring in raw materials, we do all the mixing and the electrode creation, and then, of course, we do the cell assembly. And at the moment, we're still the only full cycle plant in the UK. And obviously, there's the Northeast plant, but that focuses on the cell assembly side rather than the electrode manufacturing. So we work right from scratch. And of course, if given its history, it had to have all of those features. It can't look at supply chain variability, and it can't generate recipes. It can't generate electrodes if it doesn't have that first phase of the manufacturing. So it's a highly flexible facility. In modern day, it's small, so it's a sub 100 megawatt hour plant. But that does mean we are able to generate millions of cells a year.
Right.
So as far as a go-to-market production plant, it's more than adequate to get early products tested and out there. So that it's combination of flexibility and scale.
Yeah.
Not too large. That means you can more cost effectively look at bringing new products to market. Flexibility and but enough to prove.
And that's because of course the issue with the bigger factories, either like Sunderland, the former Nissan site, Envision AESC, where they're assembling cells but not they don't produce the raw materials. They bring in the raw materials and then they do slits the reels of material, but they're made off-site. you can't deviate from the process. Not just for cell production, but with most large-scale factories, they're set up to deliver a process, and deviating from the process is pretty hard, and it's a completely different setup if you want to be a bit more flexible and agile in terms of processing different things. So you're literally, if you're working right from the sort of powder level, so in terms of the makeup of the cell, you're mixing the slurries and doing the coating and the drying and all that kind of thing inside one factory then.
Absolutely. So obviously you're right, Ryan. Large factories, even the ones that are full cycle as we term it, are optimized around a very efficient, very high yield single process. And moving those off that process is both costly and tricky. How much flexibility is in that line is always a question. We have a great degree of flexibility. It was designed around being flexible. It comes at some of the disadvantages that we haven't got a highly optimized approach for a single line, but with all the benefits of being able to vary the product that we're looking at.
Yeah.
So for all those reasons that it was a sort of perfect setup to look at commercializing sort of next generation technologies. Yes, of course, we can make all of the standard chemistries, and in fact do and have. But our real focus is on bringing a next generation technology to market. Wow. The fact that we can work right from those early raw materials, do all the mixing and the coating, means that we can actually generate quite a strong IP base and knowledge base there.
And it's there can't be many places in the world that can do that. I wouldn't have thought.
No, obviously when the market grew up back in the 90s, grew up fast around the single product line and became highly optimized, and even the factories that you're seeing coming online now are still quite focused on very large, single product type approaches.
Yeah,
there is a massive demand for what's currently available, and so I think that's why people view it that's the technology for some years to come. The good news about what we do is everything we do can be done in those plants. In general, we have greater flexibility. It's true, but we use exactly the same equipment. So everything we do is transferable to that global scale within the limits of the manufacturing equipment. So the great news is that we have all the flexibility we need to do that, bring to market, but yet scale up is much more in line with the larger manufacturers from the Far East and the emerging ones that you're seeing in Europe. And you're right, Ryan, there isn't really anybody doing that. There are some other businesses that have similar scale of plant to us, but they tend to be very focused around single products.
Yeah.
And there are some smaller plays, entities around Europe particularly, who do some manufacturing, but on very small scales, very, very small scales.
Some of the bigger cell producers don't have their own kind of prototyping plants and stuff in-house, so they've got the mass scale production, but they couldn't, they can't easily sort of trial a new chemistry or a new technology within their own facilities because they just don't have that kind of. I think it's a peculiar sort of quirk of how the lithium industry has grown up in the last few years. It's sort of gone from nothing to light speed very quickly, it feels like. And all the focus has been on the capacity, for existing products rather than necessarily the advancing and the sort of R&D side.
Yeah, you're absolutely right. And when we talk about the business, we sort of highlight those sort of market features. That there is. I mean, if you look at the evolutions of lithium-ion over the last 20 odd years, there's been quite a lot around the sort of power electronics and the way the cells are used, but less so around sort of big steps in the actual production process for the cells. And part of that, I think, is because of that that fast growth, and of course the massive. I mean, it's very expensive infrastructure. Putting gigafactories into play is a lot of money.
Yeah.
And so once you've done that, it's not so easy to afford just to vary that. So some big decisions you have to make before you get into manufacturing or into constructing those manufacturing facilities.
And I know you probably can't tell us too much about the kind of customers that you work for, but I'm guessing that some of those very big global battery companies that we would all recognize the names of would be amongst your customer base.
In fact, what we've tended to do is worked with the end user community.
Okay.
At the moment, our view is that we will bring some of those products to market and scale our own manufacturing facilities behind them. But you're absolutely right. We're in contact with a number of large, cell manufacturers. But I think our view is that it's very difficult for big manufacturing to switch to a new product line without that new product line being well proven.
Yeah.
And that's what we can do. And there aren't that many places you can go to get that, that well proven product line that is then going to be of interest. I think when I started my career, having a presentation on the next technology was all you needed to convince people to start looking at it. And as time has gone on, it's moved from having a great idea through to a prototype will get you the interest. But nowadays you've got to really have the product available and be able to be made.
Yeah.
Before people start to take a significant interest in it. And so that's the aspect that we do and can do.
It's an interesting sort of part of, people often, I think, underestimate the challenge of manufacturing and this could be anything, not just lithium cells, but I mean, I've got some questions about the lithium manufacturing process or the cell manufacturing process. But any product at scale, the actual mass manufacture is a science and a challenge in itself. And you can have lots of things that are a really good idea and you can make kind of one or two, but then actually having a repeatable, stable, safe manufacturing process to make millions or even billions of them at scale is a completely, it's a whole other topic. And actually you can spend substantially more money developing that process than you can actually developing the base technology itself. So it's a huge challenge having those stable manufacturing processes, and then such a huge amount of the cost for a lithium battery is from the process itself. Because the manufacturing process is pretty complex, isn't it, for lithium cells?
You know what? It's interesting because at a top level, there are a number of straightforward steps that you take. But the point you're making is right. Once you move from the sort of broad brush approaches on each step of manufacturing and get into the detail, there is a blend of engineering and science that underpins the ability to make that cell that even function, let alone make it to the required standards. So I think you're right. When you're in the lab, it's easy to underestimate. I've been in the lab and underestimated myself, and I'm sure most people empathize with this. It is easy to underestimate the manufacturing part and to think that actually once I've cracked the science, the manufacturing will be the easy part.
Yeah.
But what we quite often find is that the lab performance is one thing, but bringing it into a scaled up production environment and recreating that, you don't always get the same results that you originally hoped for.
Yeah.
And the good news is we're rather good at that now, and we've been going sort of 4 or 5 years and gained a lot of experience in good start points, and we can get technologies turned around reasonably quickly now.
And of course, it all has to be done as well in a what I could only describe as a kind of hyper clean environment. The level of control of the environment in which battery cell manufacturing is done is quite extreme, isn't it?
Well, absolutely, and you're right about the controlled element, and it is clean, even though we use some pretty messy chemicals in that sense. It is a very clean environment. And again, it struck me that when I first got into this industry, knowing that there's a lot of carbon used and this, that, I expected to go into battery manufacturing environments and see, a pretty dirty environment, but absolutely not. It's not clean room style. It doesn't need to be quite that level, but there is an awful lot of control over what's done. And obviously they're all contained processes. Most of them are done in the absence of, well, certainly the mixing is typically done in the absence of any oxygen. We put pressure on. There's tight control over things that you just might not imagine when you're sort of first inventing the chemical steps to a new recipe. So it's a very controlled environment.
Right. Wow. And so just then, if you can tell us at the moment, what are the kind of things that you are working on up in Thurso? What's the plant actually producing? What sort of technologies are you working with?
So I think we've really got to that phase now where some of the next generation cells that we were scaling up are becoming available. I'll touch on two. We have a few more, but we've been working on high power cells. So obviously, automotive is a big space, and the high power cells we've been looking at have been focused on automotive end users, typically in the niche space, in the niche vehicle space, rather than sort of mass adoption. But nonetheless, we're getting quite a lot of interest from larger OEMs.
Yeah.
So we have a cell that, and you'll know the trade already, Ryan, that we can get up to 100C performance, but we can vary that a little bit in its design to bring a bit more energy back into play. So there's a couple of sort of variants in the family.
So 100C is an insane C rating for a cell, just for people who haven't kind of twigged on that, because you slipped it out there very kind of nonchalantly. So a normal energy cell that you would find in a typical EV might be rated at 3C. That's a pretty good, 3, 4, 5. 5 is really starting to push it for an energy cell. And then power cells that you'd find in a hybrid application, maybe 10 to 15 at the absolute kind of top end. So 15 is a typical kind of high power cell. Anything up, 100 is absolutely bonkers, insane. I mean, that's like ultra capacitor territory for a battery cell. It's 100C is massive power rating for a cell. So
yeah, it is, and I think the market space for that is there, but probably you're right. More of what we're doing, even though we can go up to that capacity, we are probably on the lower side of that, where we get a better balance between the energy and the power side of it. And it's not only what can it do in instantaneous levels, as you know, it's what it can do on a sustained
repeatability,
and repeat, and all the things that you have to accommodate. So again, I when I first entered the world of batteries and cells and everything, I used to look at performance specs that were being published and given out. And it's a very, even that is a very complicated space. Quite often people will publish features that it can do, but not necessarily all at once. And there's relationships between the different features that come into play, and it's a minefield of understanding what the actual cell can do. What we are clear, we always present what it can do in combination. There's really we put out. So if I put 100C on there, it would obviously have impacts on other parts of the performance. But you're right, it's really fantastic. We typically have worked with other people's inventiveness, so we don't do all the IP generation ourselves. And in this case, our power cells are linked back to my old employer, Kinetic, in this case. But they're not the only company we work with. And just moving on to another technology, we've been looking at working with sodium ion, and there's a couple of companies we work with on that technology. And our view there is that depending on which particular configuration we're looking at, but there's some great energy potential in that. Certainly within the scope of lithium ion, perhaps not as good as the best energy cells, but certainly what it also brings is sodium ion's got some really, really fabulous options to it. You can take it down to 0 volts, for instance, and it doesn't damage the cell. What that means is you can transport it as inert chemicals rather than, as a hazardous good.
Right.
So there's some strong benefits there. Thermally, very stable, but yet still achieving some strong, performance features. Slightly longer time for us to get that to market. We're still bringing that through its commercialization phase, if you will. But
and that's not like the kind of like molten salt kind of crazy batteries of the past. This is a sort of much more conventional looking battery cell with sodium ion chemistry instead of lithium ion.
Yes, I mean there are a lot of those molten salt batteries around now, so I'm not sure whether they're of the past or whether they're making a resurgence. But you're right. I wouldn't like to draw any comparisons, but no. This is lithium ion scale performance, whereas typically other sodium based batteries are looking at more like, I wouldn't like to say lead acid, but somewhere below what lithium ion performance has been.
Yeah.
So it's a fantastic technology, and I think we've started to steal a bit of a march and lead worldwide on that, really. Being able to make those cells already, although we've got to still go through some of the certification on them.
Yeah.
And the UK in general has got some strong capability in sodium ion. So that's a good starting point. And where we might see that going is initially perhaps we're not really looking to replace lithium ion in automotive. It doesn't have that sort of performance at this point. But certainly in more stationary applications where you want to trade off safety and theoretically, of course, in a volume basis, sodium is cheaper than lithium.
Yeah, very.
So it does offer some cost advantages. So a fabulous technology. So those are the sorts of things we're working on. In the background, of course, we can provide most blends of sort of off the shelf, as we call them, lithium ion. But obviously, at the volumes we work at, that's not a sustainable market position for us. So we're looking at bringing something new to the market.
Right. On the, just to circle back a little bit, on the high power cell, the technology involved there. What's probably can't tell me the full secret sauce, but what how on earth are you getting kind of 50C performance out of a lithium cell? What is it that you've done there?
Yeah. Well, I mean, any manufacturer will know that there's some manufacturing techniques that come into it, and then of course there's some IP that comes into it in the way the recipe's created in the first place. And we use a blend of those. So there's some strong IP positioning that gives us that sort of recipe that is set up for high power in the way you go about that.
Yeah. And
then, of course, the manufacturing processes rely on thin coatings rather than thick coatings. And the performances we're getting out of that are tremendous. And I think what's good about it as well is we're using a facility that was originally designed for energy cells, but it just shows you how precision you can get off of even standard lithium-ion equipment if used and set up in the right way. So there's some fantastic evolutions that we've looked at, and how you use that equipment and what you do and how you modify processes and everything else to actually get that sort of high performance out of it. So yeah, and that's true of all what we do, really, Ryan. It's a combination of that first IP coupled with extensive IP around how you make a cell repeatably perform in that way.
Yeah. And on the that it's going to be a huge topic on the lithium cells. The C rating, people might be thinking, what on earth are they talking about? Why does it matter, the C rating? But it's actually becoming more and more important, not so much for driving the vehicles, although in hybrid applications, you do need a higher power cell. You can end up oversizing a battery pack just to accommodate the power requirements of the application. But where you're really starting to hit obstacles is on charge speeds. So the limiting factor for charge speed now is, often the C rating of the pack, rather than, the infrastructure or any of the other bits and pieces. So being able to push more power in and out of a cell is really important in terms of the utility and functionality of that cell and how they're being used in automotive as we go for, these. It's not necessarily all about hypercars. It could just be about the ability to fast charge quite an ordinary car.
Very quickly, yeah. No, you're absolutely right, Ryan. And I think there's also a note there that not everything that discharges charges quick. Not everything that charges quick discharges quick. So
yes,
you bring, again, it's interesting when you look at performance specs. You have to be a bit of an expert really just to understand what that spec is actually telling you. And I think it's quite a complicated space when you get into that. But you're absolutely right. I think the reason why we tend towards niche than mainstream is because it sort of circles back to part of our conversation earlier. It's all about early adoption rather than I need mass adoption of something that is available in the very near future and of course has been made for many years using the same process, and I can guarantee I'm going to get that.
Yeah.
So in the main, that type of cell is what the larger vehicle manufacturers need to secure. But there are spaces where people are starting to now look at, well, I need to differentiate my product from what everyone is buying, and that's the space we occupy. So we knew this would be a venture that would take a good few years to move from start to the end, and we're well on our journey.
It's I mean, in some cases, I remember 5 or 6 years ago, you could get pretty much any cell from any manufacturer, and often they were kind of incentivizing you to try and design their cells into particular applications. But as the kind of that mainstream has taken off, it's actually sort of self-serving in that it's really hard to get mainstream cells for niche applications. So even if they were the most suited cell, which they often aren't, you think, oh, well, I'll tap into that kind of high volume cell that's being used in over there, but you can't get them. There's no, the cell manufacturer won't actually even support the niche application, let alone, be able to access the sort of the cost, that volume leverage costing that you think you might be able to get access to. So it's kind of complex market dynamics at the moment on the battery side, and it's great to see you guys coming through with some really different things. So I look back to the high power lithium for the sodium cells. How far away do you think they are in terms of being ready for commercial and maybe in different applications? But what do you?
Yeah. I mean, look, we can. So we enter another world of different processes when we can make the cell, and that's fine. But obviously, for it to be in general use, there's a number of things we have to do to certify it, and to some extent, the end use is part of that certification process. It's not as straightforward as just saying, well, here's a fully certified cell that you can use. That if it's then integrated into a pack, that has to have some degree of certification. If it's then integrated into an end application, whatever that might be, a standalone storage solution or a car or a laptop, whatever, those go through a certain degree of certification. So it's quite an interesting space there as well to work in when you're bringing those sort of new products to market. And in some cases, you also, but the other thing you have to do, and very often gets forgotten, is we can plow ahead with, being able to make cells, but we need a supply chain that comes, along at the same pace. And again, if you're changing some of the chemistries, then that supply chain is typically new.
Right.
So those are the things that take the time in the main. Look, we can make those cells now, but our view is certifying and scaling up supply is probably putting us somewhere up to the next 2 years. And I think it could go very fast as demand comes up.
Yeah.
And obviously that means everyone looks to go faster. So you're sort of a demand-led phase now.
Right.
But I think we could be in quite reasonable production within 2 years. And certainly we can supply those types of cells a sort of pre-certified position now.
And what market is really pulling the demand for those? Is it automotive or aerospace or something?
So there's a lot of interest in aerospace, but that's typically a field adopter, if you will.
Right.
It's more energy storage that we've been looking at. That sort of demand side comes from. It's particularly its ability to be very stable in high temperatures. Lends itself to sitting alongside things like solar plants. And yes, of course, lithium ion can be, temperature controlled and engineered to be very robust and safe. And we never really come in with a view that the sodium ion is safe and lithium isn't. Of course, lithium is safe. It's used globally in all sorts of environments. But there are situations where different chemistries, different products are best suited, more optimally suited. And I think that's where we see sodium ion. But we're not ruling out transport. We can, we certainly believe we can get up from the levels of energy we're at now to, be very competitive with, energy cells in lithium ion, and therefore automotive is still a market that we could grow into.
Okay, interesting.
And I suppose the other good news about it is, again, because we're using a standard lithium ion plant to make the cell, it's ultimately transferable.
And that's quite different from in the past. I think the technologies were radically different in terms of the manufacturing process, and the amount of capital investment that's gone into lithium production, sort of reel-to-reel type production processes is vast. So people aren't going to want to write that off, and being able to improve on and push new technologies into those huge processes is, it's really exciting in terms of what that might bring in the future, because that lead time to bring new things on should, in theory, get shorter as a result.
Yeah, and you're right. There's a lot of different non-sort of lithium-ion derivatives out there, and you mentioned some earlier, some of the sort of salt batteries that are being pushed, and they have all sorts of different advantages. But I think one of the things that is easy to overlook is that magnitude of capital investment required to get manufacturing up and running, to get the right volumes, to get the right price, to get the right quality. It's not a straightforward part of the journey. I think what we do in our business is, for lithium ion and derivatives, we bridge that challenge.
Yeah.
We already have the plant. We can already get those products up and running. And you're in a unique space. You said that earlier. There aren't really people in the space we're in. That's held out by our client base that we now have. Some global brands from overseas that have been telling us that we're one of the few players in the space if you're looking for something that's not what you can get right now.
And that's a kind of neat little segue into the other things you guys are working on at the moment. So I know there's been a lot of press around this the last few weeks, and I also know that there's a bit more to the story than what has been reported. But you've got some pretty ambitious plans as a business in terms of scaling up and growing the company beyond what it currently is. So could you tell us a bit more about that, please?
Absolutely. So the reality is we need to grow, both because the demand that we're now seeing, and we also know that we need to get the volumes up to get the pricing points right. We are seeing that demand growing beyond where our plant is going to be able to keep pace. And there are some upgrades we can do to the plant to increase capacity, but in reality, we're looking to build, using the Tesla term, Gigafactory, that is pretty commonplace now. But gigaplant is another phrase that we've been using just to try and put a differentiator there.
Yeah.
We're looking at our own, and have our own plans, and we actually have our own design of a factory that will go up to sort of 3 gigawatt hours. We've done quite a lot of work on the product lines that we think will be at that scale. We've made sure that the equipment is designed to allow that. We've identified a couple of locations. One is sort of Teesside, one is in Dundee. I think we've been public about those.
Yeah.
And we're ready to push forward with that supply base as that demand comes to the company.
Right.
And of course, it is one of those challenges that people look at new technologies, but want to be very confident that they're going to be able to get enough to the right quality for a duration. Particularly in automotive, it's a sort of 5-year play to get a vehicle up, and then it's a 5-year play to have a supply in place. We've done.
That's a big factory. I mean, 3 gigawatt hours. That's bigger than the old Nissan plant, the ASE Envision site. And you would be, presumably that would be the same model. You'd be a kind of powder to power type plant as well, full process.
That's right. So, and you're right. It's a big plant. I think it's 37,000 square meters or something. It's a building that's going to be sort of 15 meters high. It will be a very big building.
Wow.
And a very big space. And that we look at different options from new build to existing space that can be converted. And with that last option, Dundee has a site that is becoming available that has the sort of capacity and space. So those buildings are there.
Yeah.
They're not easy to find. But the reality is it's other features like power, energy that are core. This is a process that demands a lot of power, and ensuring that power is renewable, is green, is as least carbon as is possible is quite key. There's a obviously you can put factories up anywhere, but if you're using, I'm not saying anyone is doing this, but obviously just for illustration, if you're using coal-fired power to generate those batteries, the entire footprint of CO2 is worse than if you were using a renewable energy source to power the factory. So those are big considerations. So the reason we looked at the sites we're looking at, power was one of those most fundamental issues, and making sure that we were green. And of course, Scotland and other areas such as Teesside, they have wind energy, they have solar, they have a lot of renewable available. So those have been sort of part of our choice and selection criteria.
Wow, and this is still aimed at those sort of niche specialist applications, right? This is not you kind of trying to make a plant to make many of one chemistry. This is still your original business model, lots of variability, lots of complexity, bringing the really exciting new stuff into the marketplace.
I mean, to a degree, obviously, as you get larger, you do build out some of that flexibility. You have to, but nonetheless, keeping flexibility is key for us. And you're right. And just to give some perspective, I mean, if every vehicle in the UK, those 1.5 million vehicles, or between 1.5 and 2, depending on which year you look at, were all electrified, that's 60 to 100 gigawatt hours of cells required.
Right.
And we're talking about 2 or 3. So in the scale of the market, we are still looking at a more specialized factory. But it's going to be with those products that you can't typically buy off the shelf at the moment, and there's a huge market space for that.
Yeah, wow. And then, of course, as if one gigafactory wasn't enough, there's the other gigafactory.
So we've had our plans to build our factory for some time, and I don't think it's a secret that there's been mention of a need for a large scale Tesla type size, sort of 30 plus gigawatt hour facility in the UK to help automotive, but also let's not forget there are some other markets that buy into cells, and energy storage is emerging as a big market space as well. We were looking at designing our plant, and we were introduced to a company called British Volt, who were looking at bringing to the UK shores a large, I would say more traditional, more mainstream manufacturing facility up to 30 gigawatt hours. Although who knows where that really would stop once that was in supply. Probably looking at a more mainstream chemistry that the UK really does need that capability, and the UK government has been putting a lot of effort into looking at securing that.
Yeah.
So those discussions have been ongoing for sort of 4 or 5 weeks, and we're looking at what of the different models makes sense to be common, and what makes sense to keep apart. Obviously, there are differences. We're looking at different supply chains in some instances. We're looking at different equipment specs. But there are common things that you look at, skill base being one of them. And obviously power requirements is another. So there's quite a lot of overlap, but yeah, there's differences, and they're complementary in that respect. They occupy different ambitions in client base. Although some of the clients may be the same, the offerings are very different. So it's a great link, and wherever we get to with that, I think will be beneficial for both companies, but also for the UK. That would, if we get that activity underway and both companies are successful, the UK would have a really unique position in that it would have that ability to bring new product lines to market, and the depth and volume of supply base to then take that on a truly global scale. So we could potentially march forward a few steps. I mean, we've been leaders in Europe because the factory in Teesside has been the biggest factory of cells for some time.
Yeah.
We're maybe being overtaken a little bit, but certainly
hang on, it's in fact Sunderland, not Teesside.
Sorry, yes, you're right, Lance. Yeah,
you cause a riot in the northeast.
Yeah. You definitely might have to edit that bit out. Teesside is our business, but you're right. The Sunderland business. I was referring to the 2 gigawatt hour factory.
Yeah, people forget that. Or even don't know it in the first place. Well, there's a few things, isn't there? With I was just going to say to get the UK into a better position, because actually, when you look at lithium and the history of the lithium battery, the story is a classic kind of UK, great at innovating, actually not so good at scaling up, and it's such an important technology that was developed in the UK, came out of UK academic research. I mean, even through the work with the AEA and AGM at the time, as it was, establishing all that initial business. But then, when it really took off for lithium, the sort of the powerhouses of lithium battery manufacturing now are the Koreans and the Chinese and Japanese to a certain extent. So really, Asian kind of dominance in that space, and it would be absolutely fantastic to see the story kind of turn around a bit in terms of being able to grow that UK supply chain, that UK kind of industry around what was a UK innovation.
You're absolutely right, and again, I think. Depends on when you look at history about the UK being good at industrialisation. Obviously, at one point we were very good at it, but in more recent times, you're absolutely right. It has been a bit of a story that we are fabulous at the innovation side. We are brilliant at high value manufacturing. There are still some very strong industries in the UK that sit in those spaces. But when it comes to very large volume production that has typically found a home elsewhere.
Yeah.
Look, and it's some people concerned about Brexit. Some people have had views since the pandemic that the supply chain being offshore is a challenge.
Yeah.
And putting an onshore supply chain in place is something that should happen in many different industries. So it's getting a renewed focus, and energy has been power has been one of those spaces that we have been rather good at over time, and bringing the batteries as a sort of volume manufacturing back into the UK would be fantastic, and that's part of our aim.
And so it always, I mean, I know it is a complex field, but from my perspective, certainly my experience, a lot of the challenge in the UK with these things has been essentially a lack of, I don't know what you might call strategic investment, or, despite the fact we've got these sort of two ends of the spectrum. So in the UK, we're very good at innovation and sort of that side of things. And we've also got like a global powerhouse of a financial industry, but we've been very bad at making the two play nicely together. Sort of that kind of long-term strategic investment that's been needed in strategic manufacturing capacity for all sorts of different things, but including battery cells has been really, really hard to come by in the UK, with actually often, UK investors preferring to back overseas companies rather than doing it in the UK. So how, now you guys are involved in these two massive programs where, there's a lot of investment going to be required. How are you finding that side of things in terms of getting the support to do this sort of stuff in the UK from the private investment community?
I mean, you've summarised it really rather well, and we've both sat in different environments. I remember one particular session where we were both on a different panel and talking about investment and how difficult and challenging it is, and it is difficult. You're right. Investment does tend to go overseas, and strangely, we tend to attract overseas investment against big projects like that in the same way. So, look, we've got a fabulous community that are backing us right now and are taking us through those first phases, and we'll need to get the funding behind larger factories. We've had a number of discussions with UK and overseas entities about how we might do that, and I think there's a good degree of appetite for a strong business case, but it isn't easy. You do have to find investors that understand the space they're investing in.
Yeah.
And a lot of investment talk about being experienced in technology, but there are two sides to technology. There are soft tech and hard tech, really.
Yeah.
And it's the hard technology, the hardware side, where I think there's been less experience of that investment.
Yeah.
But then all of a sudden, infrastructure projects is something that we are good at investing behind. So you start to move from technology investment into infrastructure investment, and you end up in front of different entities. So we've had some very strong conversations as we've moved this forward, and I think we're aware that there's a need for us to get demand proven, and the UK has put the UK BIC into being, or not quite into being yet, but very soon to be into being.
Yeah.
Which will give us the ability to use a sort of large scale factory and get that demand up and running and proven. And then I think you're more in the space of infrastructure than you are in a sort of large scale technology investment. So you're in a slightly different space then.
Yeah.
So that's the way we look at it, and we're confident we'll be able to get this done.
Brilliant. And what sort of timescales do you think you're looking at for your? I guess the most advanced is your first Gigafactory, the smaller of the two. What kind of timescales do you think you're looking at?
The reality is both ourselves and British Volt are looking at a sort of 2023 timescale to get something in place. We've already done the design work behind that. We've already got a lot of the fundamental aspects complete. So we're ready to go. Now, our view is that the financial environment that we're in has obviously changed, and we may not have seen the full exposure of that just yet. But we weren't focused on the next 12 months or even the 24, but more 36. So our view is that we could be part of that economic recovery. Certainly in the past, programs of this nature have played an important part. Renewable energy came online, for instance, in a big way to take up demand as it came out of previous recessions, previous downturns. We see ourselves as being in a very similar place, and I think there's generally been fantastic government support. That's also going to be a key part of this. So, government looking at helping to stimulate ambitions such as ours. We've had some fantastic support up to date. There's been some other things going on in the world that has taken that focus, but I hope we'll be seeing that come right back into the markets in the near future. As I've been involved, and no doubt you have as well, in lots of economic recovery discussions, both in Scotland and the UK, and making a sustainable future is where I see a key need, and I think we're looking for the government to maintain the track that they took before the pandemic.
Yeah. And it does. I mean, it feels like the right time. The people seem to be, talking a lot about a kind of green recovery, clean recovery, new Green Deal. I don't know whatever your kind of terminology is, but it seems to be the same kind of intent. And obviously the pandemic. Lots of. It's been a bit of a wake up call, I think, for people in terms of making more sustainable business. The importance of public health. Some massive. Strategic manufacturing as well. That's all of a sudden is what we don't have the manufacturing of component X. It's all out of Asia, and I think there's sort of lots of moving parts, obviously, but it does feel like the general direction is behind where you're trying to go, certainly. So best of luck to you there. I think it's absolutely fantastic what you're doing. I really do. It's going to be an awesome legacy when you manage to get there. So just to wrap up now, because I'm looking at the time, we've gone over as has become customary for my interview podcasts these days. But it's just been so interesting hearing all about what you've been doing.
Say. Yeah, it's a lot to say, and it's an exciting space. So I'm not surprised.
Yeah. What do you think? In terms of the wider market, what are you most excited about that's coming for the future? What's got you really looking forward to the next 12, 24, 36 months?
I mean, look, I've talked a little bit about the power side of our business, the high power side of our business, the cells that we're developing and looking to bring to market there. I think we see some very exciting opportunities sat in our pipeline right now, and we hope to convert some of those, in the next 6 or so months. So those are the sort of exciting developments we're seeing in the short term, and that will then lead to us scaling up behind those opportunities and demand. But I really think in some of the cases we have other technologies that could scale on a global level. So things like the sodium mine that we're incredibly excited about, albeit that it's perhaps not on the same timeline as the high power work we're doing, but its potential is just huge. And as I said earlier, the UK has built up a reasonable degree of expertise that goes behind everything we do, and obviously there are other people in the space, and we're getting a bit of a good reputation there. So I think there's some very exciting opportunities to move forward. And lastly, the combination of a British Volt style manufacturing base with our own, just that combination, the ability to take all the innovation that the UK has always been very, very strong at, and turn that into a manufacturing base, a supply base, that is just incredible, and could be a huge market with huge job creation around that. And I think that's what excites me the most, actually. That those sort of combinations where we work with people like Bridgevolt, or even if we just work independently in the same space, that's the combination of what's happening here is very exciting.
Brilliant. That's absolutely fantastic, Kevin. Thank you so much for taking the time out to join me today. It's just so fascinating to hear about you. I think AMTE is a real, almost like a hidden gem, I would say. Not least the location up in Thurso, but
an emerging gem.
Emerging gem, yeah.
We like to look at ourselves, but you're right. We've kept patient because making lots of noise at the wrong time is as damaging as when you're ready, it's much better. So we feel we're ready now, and that's hopefully we will come out as being a hidden gem, and hopefully you'll hear and see more of us as time goes on.
Yeah, and hopefully anyone who listens to this, not even hopefully, you can tell. I mean, the depth of experience of AMTE and your team. I mean, it's vast. It goes back to the origins of lithium cells themselves. So it did make me laugh a little bit. Some of the press coverage recently talking about you being a startup. I was actually, the first time I read that, I thought, is there a different AMTE Power? They picked the same name. It can't be the same company because they're not a startup. But lazy journalism. So yeah.
Well, it's one of those balances. We obviously started AMTE in 2013, but bought into an existing base of production. And and I think you also made a great comment about the first Gigafactory in the UK, which of course has been the first Gigafactory in Europe already here up in Sunderland, and has been here for a long time. We play a little differently in that we're looking at that full cycle, but again, it's one of those situations where we must remember we have got a fantastic position and history here, and it's all to be built on. Fantastic.
Thank you so much, Kevin.
Thank you very much, Ryan. It's been a pleasure.
Thank you for taking the time out to listen to the Avid Technology podcast today. I hope you've enjoyed that as much as I did. Kevin, wow, I mean, what a fantastic story around AGM and AMTE Power. Brilliant of Kevin to give his time up today when he's obviously so busy trying to sort all this stuff out to come and talk to us. I hope you got something from that and learned a little bit about something that's going on in the battery industry. If you've enjoyed today, please don't forget, hit like, leave us a rating and a comment, depending on which platform you're listening to us on. It's mind-blowing the number of people now that are listening to the show across what is a huge range of platforms. So we do really appreciate all the engagement and the questions and things that come in. So keep those coming, and don't forget to subscribe to the show so you get the next episode as and when it happens. So that's all we've got time for today. Thank you so much again, and I really look forward to speaking to you again soon.